Hello everyone, in this video we are going to see about the subject control system unit 3 frequency response and system analysis polar plot. At objectives, at end of this video we gain a knowledge of about various methods for analyzing the frequency response and system stability. Polar plot. First, what is meant by polar plot? Generally, polar plot is a plot that can be drawn between the magnitude of g of j omega versus the phase angle of g of j omega on the polar coordinates. The frequency in the polar plot is generally vary from 0 to infinity. The polar plot is drawn on the polar sheet, which is of the form of a graph. That is, this graph consists of the concentric circles and radial circles. The concentric circles represents the magnitude plot of the polar and the radial lines represents the phase angle of the polar plot. And then each point on the polar graph displays the information about the magnitude and the phase angle. Why means at first of this slide, this polar plot is generally plot that is drawn between magnitude and then phase angles. That's why each point on the graph displays information about the magnitude and then phase angle of the polar plot. So these are all about the introductions of the polar plot. Then this extension of the polar plot is our Nyquist plot. Then why we go for polar plot means, that is our advantages and disadvantages means. First, the advantage is it depicts the frequency response characteristics over the entire frequency range in a single plot. Entire frequency range means up from 0 to infinity. And this polar plot is much easier to determine both the phase crossover frequency, that is our omega pz, as well as the gain crossover frequency omega gc. So these are the advantages of our polar plot. And then the one more drawbacks in our polar plot is this plot does not clarify, that is the contribution of each individual factor of the open loop transfer function. It does not indicate clearly. So this is one of the drawbacks of our polar plot. And this is our representation of the polar plot. Then here we take in the x-axis, here we have 0 degree, and then here we have one unit circle. This is our polar graph representations. And then this circle represents the unit circle, and in this polar graph we have to represent the points in terms of magnitude, that is magnitude of g of j omega, as well as we have to plot the points in the form of phase angle that can be represented as angle of g of j omega. Here the blue line indicates the degree of positive angle that can be measured in terms of anti-clockwise direction. Here the negative angle, that is from 0, minus 90, minus 180 degree, that can be measured as clockwise directions in our polar graph. Then both the angles are measured with respect to the reference point, that is our 0 degree. Generally, the transfer function g of j omega is represented in the form of rectangular form. Generally, rectangular form can be written as g of j omega equal to g into real part of j omega plus g into imaginary part of j omega. Here we have integral factor and then derivative factor in our transfer function of the control system. First, the integral factor of the polar plot is given by g of s equal to, just for our example, g of s equal to 1 by s. And then next step we have to substitute wherever we have s terms, that's just we have to replace by j omega, and then g of j omega equal to 1 divided by j omega. Generally the integral factor can of the polar plot is our negative imaginary axis. Then next one, the derivative factor of the polar plot is given by g of j omega equal to, just we have s term, that is in the second step we have to replace the s term by j of j s equal to j omega. So g of j omega equal to j omega. So it represents the positive imaginary axis. Then if we add and poles are zeros to the existing transfer functions, what are the effects in the polar plot means, the first condition is, if we add the poles to the polar plot means it will shift its end by minus 90 degree. Suppose we can add zeros to the polar plot means it will shift its end by plus 90 degree. These two concepts are very important in our polar plot consideration. And next we are going to see about the type and order of the system. Why we have to know for the type and order of the system means, to sketch the polar plot of g of j omega for the entire range of frequency, that is from 0 to infinity, means there are 4 key points that usually need to be known. What are they means? The start of the plot, that is where we have the initial frequencies, and the second key point is the end of the plot, that is where omega equal to infinity. Why we have to find omega equal to 0 and omega equal to infinity means, generally our polar plot can be drawn for the range of 0 to infinity. That's why we have to assume that omega equal to 0, that is our start of the plot, and then end of the plot where omega equal to infinity, where, and the third point where the plot crosses the imaginary axis, that is imaginary of g of j omega equal to 0, and the next point is where the plot crosses the real axis, that is real of g of j omega equal to 0. So first, the type of the system in the polar plot determines the quadrant where the polar plot starts. That means the type of the transfer function, it determines the where the polar plot starts. And the next one, the order of the given transfer function in the polar plot determines the quadrant at which the polar plot ends. This is our type number of the system representations. Here we have real axis and then imaginary axis. In that we have 4 quadrants. Then this point indicates the start of the type number 0 system, and then this point indicates the type 1 system starting point, and then this point indicates the start of the type 2 system indication, and then this point indicates the start of the type 3 system. So this diagram represents the pole of all the poles of our polar plot. And the second diagram shows that the poles of the all poles in the polar plot where we have to ends the polar plot. Here this representation indicates the end of first order system, and this arrow mark indicates the end of our second order system, and then this arrow mark indicates the end of our third order system, and then this point indicates the end of our fourth order systems. So these are all about the type and order of the systems. Once we have to remember this, the type of the system indicates where the polar plot starts, and then order of the system indicates where the polar plot ends. And then polar plot for some of the standard transfer function is, the first condition is type 0 order 1 systems, that is the general transfer function of type 0 and then order 1 is g of s equal to 1 divided by 1 plus st. The diagrammatic representation of the polar plot of type 0 order 1 system means we have to start at omega equal to 0, in the sense means where we have start means, that is type 0 system will start from this point and the omega value increases to 0 to infinity, in the sense the polar plot ends hence indicates the order of the systems. Here we have order 1 system, so order 1 system, the indication is here. So the polar plot for this general transfer function will be, it will be start from this and it will be end at the omega equal to 0. And the second case is type 0 and then order 2. Then the general transfer function of this type 0 order 2 system means, here g of s equal to 1 divided by 1 plus st1 into 1 plus st1. How we find this type 0 and then type 2 system means, this type number indicates how many poles are existing our origin, and then order of the system indicates that how many number of poles are existing our transfer functions. Then the type 0 order 2 system, here we have the polar plot for this type 0 and the order 2 system means, here we have type 0 system means, the type 0 systems, that is here we will have the type 0 system indications, that's we start from omega equal to 0 and then we increase our frequency omega to infinity, in the sense means the polar plot ends at order 2 systems. Here in general this is our order 1 system and this is our order 2 system. So here we have type 0 means, here we have start at 0 degree and it will ends at order 2 means, that is our angle is minus 180 degree. Here in the first case type 0 order 1 means, here we start at omega 0 means the phase angle is 0 degree and it ends at the order 1 system means omega equal to infinity, and that we have a degree of minus 90 degree. Then next we are going to see about the standard polar plot of our type 1 system and then order 1. Then the general representation of our transfer function is g of s equal to 1 divided by s, and then polar plot can be like this. Here type 1 means, how we find this, here it is a type 1 system means, in the denominator we have one s term, that is the poles at origin indications, and then order 1 is, here we have only one pole. So we have to start at order 1 systems, then here it is we have to start at this, that means type 1 system means here type 0 and this point is our type 1 system. So we have start this point and then we have end at this point. Here we have where we end means order 1 systems. So here we have the type 0 and then order 1 system. So we have to terminate this point. Here we have omega equal to 0 means omega equal to infinity. In this point we have the phase angle is minus 90 degree. And then second case we have to see in about the type 1 and then order 2 system. The general transfer function can be written as g of s equal to 1 divided by s into 1 plus st. How we find it is type 1 system and then order 2 system means, here in the denominator we have one pole at origin, so it is called as type 1 system, and at last in the denominator we have two s terms, that is the indication of our poles. Here we have 2 poles, so this transfer function is the indication of order 2 system. And the polar plot representation is like that. How means, here we will start at type 1 system means omega equal to 0. In this we have minus 90 degree. So we start this point and then increases to omega equal to infinity means this polar plot ends at order 2 system. That means the corresponding phase angle is minus 180 degree. So for type 1 and then order 2 system, the polar plot starts at minus 90 degree and it will be ends at minus 180 degree. So it is the indication of our type 1 system, and then here we will have order 1, order 2. This is our polar plot of type 1 and then order 2 system. Next we have to consider the type 1 and then order 3 system. Here type 1 indicates we have poles at origin, here only one poles at origin. At last we have 3 poles at the denominator term, so it is the order 3 system. And the diagrammatic representation of this transfer function means, so we have to start at type 1 means we have to start at minus 90 degree, that is omega equal to 0, and it will be end at order 3. So here we have order 1, order 2 and then order 3. And then next case is type 2 system and then order 4. How we find this type 2 system means, here in this case we have in the denominator s square. This s square indicates here we have 2 poles at the origin. At last in the denominator we have here one pole and then here one pole and then here we have 2 poles. At total we have 4 poles. That's why it is called as order 4 system. Here it is the diagrammatic representation of our polar plot for type 2 system and then order 4 system. So we have to start at type 2 system means here we have type 0, type 1 and then type 2. So we start at minus 180 degree and it will be end at order 4 system. So in general it is order 1 indication, order 2 indication, it is order 3 indication, it is order 4 indications. So these are all about the polar plot for standard transfer function. Next we are going to see about one example. The given problem is, here the open loop transfer function for the unity feedback system is given by g of s equal to 1 divided by s into s plus 1 into 2s plus 1. Sketch the polar plot and also determine the gain margin as well as the phase margin. This is our given questions. For this question we have to sketch the polar plot as well as we have to determine the phase margin as well as the gain margin. So first we have to write the given transfer functions. The given transfer function is g of s equal to 1 divided by s into s plus 1 into 2s plus 1. Generally we have to approach this problem how means, first we have to know what are the procedures we have to solve this problem. So the first step is just we have to express the given expression of open loop transfer function in 1 plus st form, and in the second step we have to determine the type of the system as well as the order of the system number, that is order number and then system number. After that we have to substitute wherever we have s, it can be replaced by j omega in the expression of g of s into h of s. After that we have to separate this in the form of magnitude terms as well as and then angle terms. Then after that the separations of magnitude term and then phase angle terms, we have to tabulate various values of magnitudes and then phase angles of different values ranging from omega from 0 to infinity. Usually the choices of different frequencies it will be a corner frequencies are around the corner frequencies only. After that choose proper scale for the magnitude axis, and after that we have to fix all the points in the polar graph sheet and join the points by a smooth curve. After that write the frequency corresponding to each of the point of the plot. These are all the steps we have to followed in problem solving. So in the first step we have to write given transfer functions in the form of g of s into h of s. Then the first step we have to identify the type number and then order. Here we have at origin we have 1 poles, so it is the type 1 system, and the denominator we have here 1 pole and then here 1 pole and then here 1 pole. So at last finally we have 3 poles. So it indicates the order of the systems. At last from the given transfer functions we depict that the system is type 1 and then order 3 system. After that we have to substitute s equal to j omega in the expression of g of s into h of s. So here g of s into h of s. Why we didn't substitute this h of s means it is in this given transfer functions we have unity feedback system, that is h of s value is 1. So we have to substitute s equal to j omega in the given transfer function means g of j omega equal to 1 divided by j omega into j omega plus 1 and then 2 j omega plus 1. After the substitution of s equal to j omega in the expression of g of s into h of s means, and we get g of j omega and h of j omega. After that we have to get the expression for magnitude of g of j omega into h of j omega and then phase angle of g of j omega and then h of j omega. So it will be right in the form of magnitude and the angle. So we can write it like this. So g of j omega equal to, here we have in the numerator we have 1 divided by, here we have j omega. So omega into phase angle we are having 90 degree. So for this term we will have magnitude in the sense 1 plus omega square, that is square root of 1 plus omega square, and then angle representation is tan inverse of b by a. Here we have b terms, we have omega. For this term the magnitude will be square root of 1 plus omega square into 2 square, and the phase angle representation is angle of tan inverse of omega 2. So this is our expressions for magnitude and then phase angle. Then we have to simplify this term means, so magnitude of g of j omega equal to 1 divided by, so we have to factorize these two terms, 1 plus omega square into 1 plus 4 omega square the whole power 1 by 2. So we have to factorize in the sense, so 1 divided by omega into the whole square root of, we have to multiply this each bracket terms. So at last we get 1 plus 5 omega square plus 4 omega power 4 the whole power 1 by 2. This is our magnitude representations. After that the angle representation is the phase angle g of j omega equal to, so in the numerator we didn't have any terms, so no phase angle for the numerator term. In the denominator we have one pole at origin means, so we have minus 90 degree. After that minus tan inverse of omega and then minus of tan inverse of 2 omega. So generally the polar plot starts from frequency range omega equal to 0 to infinity. So you have to substitute in the general expression means g of j omega equal to infinity. So the angle is minus 90 degree. Then we have to take omega L to infinity in the sense we have g of j omega equal to 0. The angle is minus 270 degree. We have to tabulate the magnitude and phase of at different frequency ranges. We have to tabulate the column, that is we have to separate the columns of 5 and rows of 3 rows. So in the first column we have to take the descriptions, that is for the first column indicates the radians, that is omega, and the second row representations of magnitude of g of j omega, and then third row it represents the phase angle of g of j omega. Just we have to take different values, that is usually it is the corner frequencies. So we have to take 0.35 omega value, and then just we have to substitute in our expression the magnitude of g of j omega equal to 1 divided by omega into square root of 1 plus 5 omega square plus 4 omega power 4. Then wherever we have omega means just we have to substitute 0.3. So at last we get for omega equal to 0.3 we have a magnitude of 2.22. Correspondingly for omega equal to 0.35 we have a phase angle of minus 144. How means just we have to substitute the omega equal to 0.35 in the general expressions. The general expressions in the sense, that is g of j omega equal to minus 90 degree minus tan inverse of 0.35 minus tan inverse of 2 into 0.35 means we get an angle of minus 144. Similarly, second, we have to substitute omega equal to 0.5 in the general expression, means we have an value of 1.2 and then phase angle of minus 162 degree. And then third frequency value is 0.6. Then the magnitude value we get is 0.9. After the substitutions of the phase angle expressions, for 0.6 frequencies we have a phase angle of minus 171 degree. After that we have to substitute omega equal to 0.7 in the expression, magnitude expression, means we have get 0.7 and then phase angle is minus 180 degree. And then last omega value is 1 and then we have to substitute in the formula, we get magnitude will be 0.3. At last the phase angle is minus 180 degree. So these are all about the magnitude and the phase of different frequency ranges. After that we have to choose proper scale for the magnitude circles and fix all the points in the polar graph sheet and join the points by a smooth curve. Here the first corner frequency have to take it omega equal to 0.35. So the corresponding phase angle we get is minus 144 degree. So we have to plot in this. This red color line represents the omega 0.35 and then corresponding phase angle value. Then the second omega value is 0.45. So here we can plot this point and then corresponding phase angle we have minus 162 degree. And then third we have omega value is 0.6, means we have an corresponding phase angle is minus 171 degree. At omega equal to 0.7 means we have an phase angle of minus 180 degree. This point is the point of intersection of our polar plot, cuts our unit circle. And the next one, the last point is omega equal to 1.0 means we have an phase angle of minus 180 degree. So approximately this point. So this is our polar plot. Then we have to start at, so this is our polar plot representations. So from this plot we can clearly indicates the magnitude and then phase angle for each values from omega equal to 0 to infinity. So how we start means, here we have type 1 system. So we start from, then it will be end at the order 3 system. It will be clearly we have known from this polar plot. After this, we using this polar plot, we have to find out the phase margin and then gain margin. Then the magnitude circle cuts the 180 degree axis at 0.7. So that this is our intersection points. So the point is 0.7. So this 0.7 is our value of GB. The general expression for gain margin is, that is the gain margin is indicated as kg. That is gain, generally in the control system we have to gain indicated as k. So kg equal to 1 divided by GB. Here the intersection point is 0.7. So kg equal to 1 divided by 0.7. At last we get gain margin value is 1.428. After that we have to find the phase margin. Generally the phase margin formula is the phase margin, that is pi. Here we take it as phase margin y equal to 180 degree plus theta. How we find this value of theta means, here this here we have the polar plot cuts this unit circle at this point. At this point the corresponding phase angle is minus 168 degree. This is our theta value. So we have to take it as 180 degree plus theta. So here 180 degree. So here we have minus 180 degree, sorry, minus 168. So 180 degree minus 168 means at last the phase angle is 12 degree. So at last the gate margin is 1.428 and the phase angle is 12 degree. So these are all about the polar plot for different values of frequencies, that is from 0 to infinity. From the representations of the polar plot, we have to calculate this gain margin and then phase margin. So now we have a clear idea of our polar plot. So these are the references I used to make this polar plot video. Thank you.